You've heard the name Isaac Newton, maybe in relation to that famous quote about apples or gravity. You might have learned about his 3 laws of motion in physics class. You might even know that he helped develop calculus. Or perhaps you know that he came up with the laws of gravity. If you haven't yet watched our previous videos on Albert Einstein and Nikola Tesla, we'll link them at the end. In this series, we look at how some of the most brilliant people ever came up with their most famous ideas and delve into what made their brains tick. But these geniuses weren't perfect. They had their own faults and ticks. So stick around till the end to learn about Newton's less savory quirks. Ready? Let's take a look at Isaac Newton, the man who cracked the secrets of the universe. Isaac Newton was born on December 25, 1642 in Woolsthorpe, England. He was premature and so tiny that everyone assumed that he would die. That may be why the baby was christened 3 days later. His father, also named Isaac Newton, died before he was born. So, young Isaac was raised by his mother and maternal grandparents. As a boy, Newton was quiet and shy and didn't get along well with other kids. He loved spending time alone tinkering with machines, figuring out how things worked and solving puzzles. At age 12, he reportedly built a water clock to make up for the lack of a clock in school. A year later, he attended the King's School in Grantham, where his love of math took off after his teacher taught the class quadratic equations. He enrolled in Trinity College, Cambridge, in 1661, but when the plague forced the school to close in 1665, Newton headed home to Woolsthorpe. There's a saying that necessity is the mother of invention, and that proved true for Newton. When he was stuck at home, he couldn't help but notice things in nature around him. He noticed patterns in light, in the tides, in plants growing and changing, and of course, those darn apples falling from trees. He observed that every object in the universe seemed to obey certain rules. He realized that if he could uncover these rules, he could use them to predict how things would move and behave. He started to formulate his theories of motion and gravity. Newton continued his investigations when he returned to Cambridge in 1667. In 1687, he finally published his results in a book called Philosophiae Naturalis Principia Mathematica, or Mathematical Principles of Natural Philosophy. This is now known as the Principia. It was groundbreaking because it proposed that the same laws that governed an apple falling from a tree also governed the planets orbiting the Earth. No longer were the celestial bodies in the heavens simply objects that happened to move in predictable ways. They were subject to the same physical forces as everything else. Let's take a look at the main points of his findings. Newton's first law states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by unbalanced force. Imagine you are on a train that's moving forward. If the train suddenly slows down, you continue moving forward at the same speed until you hit something like the seat in front of you. That's Newton's first law in action. His second law tells us that the acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. Put simply, the more massive an object is, the harder it is to move. His third law says that for every action, there is an equal and opposite reaction. Think of a rocket taking off into space. The rocket blasts gas downward, and the equal and opposite reaction propels the rocket upward. These laws, along with his law of universal gravitation, form the basis of classical mechanics. The Principia also introduced new mathematical concepts and helped scientists use math to describe nature. Before Newton, scientists struggled to explain the orbits of planets and comets. Newton's law of universal gravitation explained it all. According to this law, every particle in the universe attracts every other particle with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. Simply put, the bigger and closer things are, the stronger the gravitational force between them. With this, Newton was able to show that planets orbit the sun in elliptical paths. But Newton didn't stop there. He also described how light behaves. He figured out that white light is actually made up of different colors of light and that these different colors bend at slightly different angles when they pass through a prism. He also made significant advances in optics and mathematics. He created a reflecting telescope with a curved mirror instead of lenses. He discovered that any two numbers can be exactly divided without leaving a remainder, and that an infinite series could be used to approximate the value of pi. His contributions to mathematics include the development of calculus, which is used to calculate rates of change. Calculus helps us understand how things change over time, such as the trajectory of a rocket or the growth of a population. Newton shared the credit for discovering calculus with German mathematician Gottfried Wilhelm Leibniz. But the two argued bitterly over who had discovered it first. We might never know who actually invented calculus first, but both men changed mathematics forever. Newton's work revolutionized science and mathematics, but he wasn't content with just scientific pursuits. He was also interested in theology and alchemy. He kept detailed notes on biblical prophecies and believed that the apocalypse was near. He studied alchemy, the medieval practice of trying to turn base metals into gold, hoping to find a way to prolong human life. But the device malfunctioned and burned down part of his lab. Despite his eccentricities, Newton was highly respected in scientific circles and was elected to the Royal Society in 1672. In 1705, Queen knighted him, making him Sir Isaac Newton. Over the years, Newton held several important positions, including Warden of the Mint and Master of the Mint. In these roles, he worked to improve England's currency and stamp out counterfeiters. Though he was knighted and considered an esteemed member of society, Newton had his share of enemies. One notable feud was with fellow physicist and natural philosopher Robert Hooke. In 1666, Newton shared some of his ideas about light with Hooke, who was a member of the Royal Society. Newton believed that Hooke, who was also the Society's curator, leaked his unpublished ideas to other members, including Gottfried Leibniz. The two scientists argued publicly over priority in scientific discoveries, with Newton accusing Hooke of plagiarism. Another major rivalry was with German mathematician Johann Bernoulli. Both Newton and Bernoulli wanted priority in the development of calculus. The Bernoullis even challenged Newton to a contest to see who could publish the most theorems in calculus. Newton refused, but Johann's brother Jacob published a paper on calculus anyway. Not only did Newton have professional rivalries, but he also experienced personal tragedies. He had a falling out with his mother, Joan, over money and property. Late in life, Newton became convinced that someone was trying to poison him. He carefully saved the food he ate in case he needed evidence. Although Newton never married, he had a relationship with a woman named Catherine Barton. She lived with Newton in his last years, and many believe that she was the love of his life. He left her his fortune when he died. Newton died on March 31, 1727, at the age of 84. He was buried in Westminster Abbey, near kings and queens of England. Today, his legacy lives on. His laws of motion are still used to design everything from rockets to roller coasters. And his work paved the way for future discoveries in physics, like Einstein's theory of general relativity. When we think of Newton, we often picture a man sitting under a tree watching an apple fall. And while that story may be apocryphal, it captures the essence of Newton's genius. He unlocked the secrets of the universe by paying attention to the world around him. He showed us that the universe isn't random or chaotic, but is governed by elegant laws that can be understood with math and reason. Did you enjoy this episode of Minds Change the World? Let us know what you think of Isaac Newton. How do you think his childhood experiences affected him? What are your favorite of his inventions and discoveries? Tell us about it in the comments below. If you liked it, give us a thumbs up and subscribe to our channel to learn about more brilliant minds. Remember to check out our other videos on great inventors and scientists like Nikola Tesla and Albert Einstein. Thanks for watching.